Welcome to another edition of Comment Algebra. This video is for Algebra 1, Chapter 3, Section 5, percent of change and percent of error. So this video really has three parts, three different formulas that we need to discuss. So the first one we'll talk about is finding the percent of change when something changes. You need to find the amount of change and divide it by the original. So sometimes I'll just write this as change over original. And then this multiply by 100 is there just to remind you that you need to change the decimal into a percent if you're looking for what the percent is that it changed. So a note here, watch out for this extra step that is in these problems. When you need to find amount of change, often there's a subtract. If there's a sale price that was marked down from a regular price, you'd have to subtract those to find out how much it changed. And then sometimes you add it on or subtract it at the end of the problem. So sometimes this extra step is at the beginning, sometimes it's at the end. So you really need to watch out and think about what you're doing with these numbers. So let's look at our first example. This says that last year 1,056 people voted in the city election, but this year only 912 voted. Find the percent decrease. So we're looking for the percent of change, and this time it is a decrease. And I'm just writing the formula here, so this will help me set it up. So I want to take the change and divide it by the original. So I need to find out what the change is. From last year we had this many people, and this year we had fewer people. So to find this change, that is the first thing you need to do, is this subtract problem. So when we subtract these, we get 144. So that's how many the change was. So we take that 144, put it in the numerator, divide it by the original. The original is the first piece of information we're given about this problem. So it was the last year people. So that's what we want to divide by. And if we divide that, we get 0.136, and then this gives us a 13.6% change. In this case, it's a decrease in the number of voters. Now, when we have a number that we're increasing by a certain percent, we could do it in two steps, find the change and then add it on. But it's much nicer to do this in one step. So when a number is increasing by a certain percent, we can find the new value in one step by adding the percent to 100. So we'll find example here, adding 5% to a $35 pair of shoes gives us, so we take the $35 and we have added the 100% and the 5% together, because the 100% stands for the $35 for the cost of the shoes. So we want 100% of the cost plus another 5%. So of course, changing this to a decimal gives us 1.05. And then if we multiply that, we get $36.75. Now, this is the way I calculate it, all in one step when I'm adding on sales tax or whatever. So it's just a nice way to do things in one step. So let's look at another example of this. The city of Benson is expected to grow by 7% over the next decade, and its current population is 35,000. So how many people should be planned for at the end of 10 years? So let's set up an equation. If it's growing 7% over 10 years, so that's just one decade, so we want to multiply 35,000 times this 7%, which we have added on to the 100%, to get 107%. And then, of course, I change that to a decimal of 1.07. So then multiplying this, I get an answer of 37,450 people at the end of 10 years. And notice we did that all in one step, which is very nice. All right, the second part we're going to look at is the percent error. And this is used often in science classes. It equals the experimental error divided by the known value, and once again, to change it to a percent, you times by 100. So you need to know what the words experimental error mean. A common way to say it, it's how far off are you? It's the difference between the answer you get and what we know, that scientists know is the answer. For instance, if you were just trying to measure the boiling point of water and your thermometer measured that it is 99 degrees Celsius, your experimental error, how far off you are, you'd subtract that because we know that it's 100 degrees, and so you're 1 degree Celsius off. So to find this numerator, you have to do a little subtract. You have to find out the difference between what you got in the experiment and what the known value is. So let's look at an example. In a chemistry class, Alex found the density of copper to be 8.83 grams per cubic centimeter. But the known value of copper's density is 8.96 grams per cubic centimeter. So they want us to find two things. First, find Alex's experimental error, and then the percent, how far off he is by a percent. So first we have to subtract 8.83 minus 8.96. And if you subtract these, you end up with negative 0.13 grams per cubic centimeter. Now, the negative sign is really irrelevant. It doesn't matter if he is off by being above or below the known value, which is why your book writes this as an absolute value. So if I would show you what that looks like, so we'd have the absolute value of negative 0.13. And again, the negative sign is irrelevant. It doesn't matter. And we're dividing by the known value. Well, we know the density of copper is 8.96. So again, with the absolute value, we ignore that negative sign. So I guess I just ignore it. And then when we divide this, we get an answer of 0.01451. And so we will round that off to approximately 1.45%. So Alex wasn't too far off. So once again, just to repeat, when you subtract these to find out how far off you are, the negative sign is irrelevant. It doesn't matter if you're above or below, so just disregard the negative sign in this case. When we're asked to find the percent difference, the formula is a little bit similar to what we just did in the fact that the answer in the numerator has an absolute value symbol because, again, it doesn't matter if you're above or below. You just subtract and find the difference. And then you divide that by the average of your values, and that gives us our percent difference. So I'm in the habit of, I find the average first. So in our example, she's asked to determine the volume of the cylinder. Well, by pouring water in it and measuring it, she finds an answer of 15.64 cubic centimeters. Then she does the calculation a different way. She measures the cylinder's outside dimensions and uses the formula, area of the base times the height, and she finds a volume of 14.01 cubic centimeters. And we're asked to find the percent difference of the two results she found. So let's find this denominator first. Let's find the average of her two values. And of course, you know, to find average, you add them together and divide by how many there are, in this case, dividing by 2. And we know our average should be in between these two values, and it does turn out to be 14.825. So now we can use that number in our calculations. We need to do the subtracting to find the numerator that we need. So we would just punch into our calculators 15.64, and we're going to subtract 14.01, and this will give us our difference of 1.63. So now we have both numbers that we need. We have our numerator and denominator. So let's set that up. The percent difference is the difference between the two values, which is 1.63, divided by their average. And since we are changing, they're asking for a percent, either you have to remember or go ahead and write it in that you will be multiplying your answer by 100. So if I divide those and I go ahead and multiply it by 100, that would round off to approximately 11%. So the percent difference between her two answers was 11%. All right, now I think you have all the knowledge you need for section 3.5, so have fun with math.